the idea behind the differences estimator is to create a treatment dummy. So this treatment dummy, it's either 0 if the individual I was in the control group, and it's 1 if individual I was in the treatment group. So in our example, then the y variable is just a number, so it's continuous, and this is the cholesterol level measured at the end line. The way we can understand these coefficients after running this regression is to plot the y variable against the dummy variable, and remember that the dummy variable was either 0 if the individual is in the control group, or it's 1 if the individual is in the test group. So we have 0 here and 1 here, and what we see from the y, we measure the y variable, in our case the cholesterol level, and we get a lot of data points, and we can measure, or we can calculate the mean of this cholesterol level in the control group, and we have data on the cholesterol level in the treatment group. Maybe it's below the control group. So what we have here is that this difference in cholesterol level between the control group and the treatment group is actually the causal effect of the treatment. So in this case, it's negative because the treatment group has a lower cholesterol level than the control group. And beta naught is the sample average of the control group. So this is the beta naught, the intercept, because remember that when t is 0, then this term falls away, it's 0, so you're only left with beta naught. So beta naught is the intercept, and it's the average cholesterol level of the control group. And beta naught plus beta 1 is the sample average of the treatment group. So the sum of these, beta naught hat plus beta 1 hat, is the sample average of the treatment group. To show that the coefficient beta 1 actually is the difference between these two means of the treatment group and the control group, we can just add beta naught hat and subtract beta naught hat from the beta 1 hat. So what you do here is that you just have beta 1 hat equals beta 1 hat. They should be equal, right? Because they are per definition the same, right? But you can augment this right side by adding beta naught hat and subtracting the same, right? And just rearranging so that here you get the sample average of the treatment group, that would be beta naught hat plus beta 1 hat, and you have a beta naught hat, which is the sample treatment or sample average of the non-treatment group, the control group. So beta 1 hat is actually a measure of the difference between the mean of the y variable for the treatment group and the mean of the y variable for the control group. What's important to notice here is that this average in the control group is what we would expect to be the average in the treatment group as well if they did not get a treatment.